All right, good morning, everybody. Just going through the attendance list, see some familiar names. So, welcome everybody that joined. Good to see some people I recognize. If we haven't met before, hopefully we'll get a chance to meet in the future. So we'll get started. There's an old adage in training: don't punish those who are on time. I think we'll expect a number of people to join a couple minutes afterwards, but we'll get started. So this is lead, the smoking gun. It's a presentation on lead in buildings and on construction projects. This is a webinar style presentation, which means that you can hear me, you can see me ideally, but I won't be able to see or hear you. But we have a couple of functions to help us out with that. This presentation is 2 hours. It has ample time for questions and discussions, despite being more of a remote format. So I encourage you, if you have any questions or comments or chats or anything that you want to bring into the conversation, we have two features. We have the webinar chat. Let's try and keep that to more of a general discussion aspect of things. You can ask questions in there. I am monitoring it, but if you have questions, I'd recommend that you use the Q&A section. That way we can actually record those. So after I shut this webinar down, we lose the chat, but we're able to retain the Q&A. So if there's any questions that we want to address after the fact, or maybe you want to touch base on one-on-one, it'd be really good to record that in the Q&A. So I am monitoring both. They're kind of on different screens, so you'll see my head jumping around a little bit, but I am trying to keep an eye on that as best as I can. And aside from that, we're probably good to start. I think the numbers are racking up. So welcome everybody. This is Lead the Smoking Gun. As I mentioned, lead in buildings and construction projects. To kick things off, I don't get paid unless I talk about Pinchin for a little bit. You may know Pinchin primarily for our hazardous building materials department. That's my department. That's probably what drew you into this, is this lead conversation. We do, hazardous building materials assessments, designated substance surveys, asbestos abatement, anything to do with kind of asbestos, lead, mercury, any of those designated substances. We have a lot of other service lines. We have our environmental due diligence and remediation. So any kind of acquisition or disposition, phase ones, phase twos. We do a lot of indoor environmental quality work. So if you have, maybe you have tenants in your buildings, you have concerns about people having headaches or any kind of indoor air quality concerns, we can do air quality testing associated with that. That team also does mold response or water damage. So if you have a flood or a leak or suspect that there's any mold present, you can call us and we can help mitigate that situation. We have a great occupational health and safety team. So if you have any, audits that you want completed or you have any exposure potential, that team is really great for servicing those questions. The building science team, that has grown significantly over the number of years. Its primary function is to address any kind of envelope concerns. So if you have roof leaks, they can design and replace. Building envelope concerns, structural integrity concerns, that team is very well suited to address both design and carry out those projects. We have a great construction project management team, so overseeing large-scale demolition, redevelopment of sites, kind of a full complete package. So you can bring in the asbestos side of things for asbestos abatement. We'll coordinate the full demolition. We'll do any sort of soil remediation that's needed, and then we can design rebuild of buildings. We have a great geotechnical and emissions reduction, so any kind of auditing or emissions controls. And then if you want to kind of skip the whole consulting things altogether, maybe you've got some samples you want to submit, we have a fantastic lab in Mississauga that does asbestos and mold samples. So you can go right to them, drop your samples off, and get an analytical certificate. And that's it for my discussion on Pinchin. But if you have any questions at all, you can reach out to me. So my name's Alex Brett. I'm the operations manager and GTA practice leader for the hazardous materials group. I've been in consulting for, probably should have figured this number out before I started, about 13 to 15 years now. I did a number of years in property management as well. So we're working for a larger property management firm downtown, supporting with their national programs, running programs such as, asbestos reassessment programs, PCB inventories, radon, indoor air quality. So I have a variety of experiences, but first and foremost, it's this hazardous materials department, which is, related to the asbestos, lead, mercury, silica, PCBs, whatnot. So if you have any questions as we go through, again, I'll do my best to answer. Anything that maybe it requires a little bit of a further conversation, we can take it off in the Q&A and have a conversation after the fact. I will put in my email into the chat, just so everybody has it as I move past this stage. All right, getting into the course content. So we'll do a brief introduction on lead. We'll talk about the uses and the sources of contamination. We'll talk about the occupational exposures and diseases, the health effects associated with lead. We'll talk about the regulations. This is a bit of a drier section, but it is a really important section because the regulatory requirements around lead are not always clear. So we'll try and clear that up for you. And then we'll talk about the key steps to prevent worker exposure. Just so I know everyone can see and hear me, we have another function, which is the raise hand function. Does someone mind raising their hand just to make sure that you can see and hear me as I continue on? Amazing. Thanks everybody who helped there. So historically and previously in the past number of years, Canadian workplace and regulatory regulators have traditionally focused on safety, so accident prevention. But occupational diseases have recently surpassed accidents as the leading cause of fatalities in Canadian workplaces. So exposures are a significant part of what we should be concerned with and aware of within our working industry. Lead is obviously a contributing factor to that and something to be aware of. In Ontario, this is, it's considered a designated substance. The designated substance is a substance that the government has deemed to be dangerous enough to require specific procedures for handling. Lead fits into that grouping. As far as paint goes, lead was added to paint for durability and it added pigment. The exposure to lead can affect the brain development and damage the primary organs. When it comes to lead, the primary activities that can cause exposure, demolition for one. So if there's, lead paint on walls within a building and that building is being demolished, there's obviously a potential for a release or some exposure potential depending on the method of demolition, which ties into some of these other items. So all of these can release lead into the air, sanding, grinding, torching, welding, and abrasive blasting. And we'll get into this in a little bit more detail later on. So lead in buildings, there's kind of four primary exposure potentials that we'll talk about here. First one is daily management of lead paint in older buildings. So paints in buildings prior to 1940s had high concentrations of lead. The type of building ranged, government, residential, commercial buildings. The primary concern was around residential buildings as far as daily management, because there was a concern for, you could call it consumption, ingestion primarily for children. So when we talk about management and potential exposure through management, there's a higher concern for older buildings, and there are strong US regulations with HUD and EPA. It's encouraged that Canadian landlords of older housing kind of follow along with these US regulations, make sure that materials that are potentially degrading or delaminating are properly handled, whether it be removed or reinforced or encapsulated, so that we have this reduced potential for primarily children from ingesting these higher lead concentration paints in older facilities, especially older residential buildings. Obviously, there's also a concern when it comes to disturbance of that material through restoration or renovation, which is kind of what this next exposure potential talks about. So there's various concentrations of lead in architectural paints in offices, homes, institutions. Not uncommon for a building, depending on the vintage or the age of construction, to have higher concentrations of lead within the paint within those buildings. you'll see a lot of higher lead concentrations in rust-resistant coatings, which would be more so present in factories, structural steel primers on, as you see here, the steel I-beam. May also be present in lead sheeting or mortar, which I am going to talk about in a bit more detail, but you can see here in the bottom right, you've got that rolled up lead sheeting. You may find that in, commercial settings as baffles between units to prevent a bit of to reduce the sound transfer between the units. You're obviously going to find that in more of a healthcare setting for, X-ray rooms to prevent that radiation from spreading between the two rooms. So you may find that lead sheeting in the wall cavities. As far as methods of removal, potential impacts, potential exposure, Ontario has issued some guidelines for disturbance on construction projects, which I will go into a little bit of detail later on. Um, the primary one that we reference is the EACC one, which we will talk about in a bit more detail. But when it comes to, disturbance of this paint, the highest risk that we're going to see is primarily from abrasive blasting. So when you see those types of situations, that would maybe apply to removal of lead-based paints off of tanks or I-beams. It's a particularly risky or high risk procedure. There's also a detailed US Occupational Safety and Health Administration regulation. Where you may also encounter some exposure potential is cleaning up of brownfield facilities. So factories that use lead or firing ranges. Firing ranges has become a point of discussion more frequently. There's obviously a potential for lead to be within bullets, which I'll talk about, and firing guns releases some lead particulate. There's, if the system is designed well, there's a very effective dust collection system. But those types of systems need to be regularly monitored, maintained, cleaned. And then if there's any kind of decommissioning or trying to clean up that facility, there's some pretty stringent requirements and it requires some pretty extensive cleaning. So if there is a building use change where we're, maybe taking say a school with an old firing range and we want to decommission that and make some classrooms or something like that, there's some pretty extensive cleaning because there is a potential for lead exposure there. Obviously, the individuals who are firing the guns, they need a certain level of awareness, and the system needs to be operating properly so that those people who are maybe maintaining the firing range or people who go in there to shoot pretty frequently, they're not being overexposed. So we need to make sure those systems are working very effectively. And when it comes to, decommissioning those facilities, cleaning is kind of the first approach. It can be very effective, but if the dust or the contamination is extensive, we may look at encapsulating those surfaces to create an effective seal. And last one, which I did touch on a little bit, industrial hygiene when it comes to controlling worker safety in lead using industries. So, you know, plumbers who work with lead solder a lot, or metal workers who, handle lead a fair amount. There is a potential for them to have a higher level of exposure based on just the frequency that they're handling the lead-based materials. So we want to make sure that there's administrative controls in place. We'll talk a little bit about the PPE, but making sure that the approach to handling is adequate for the potential exposure. They can be exposed to a lot, and they need to understand the risks associated with that alongside some controls. So talk a bit about the uses of lead in construction and industry. So what is lead? It's one of the most abundant heavy metals on Earth. It is an element, which means it cannot be created or destroyed, and it is very dense. So if you're maybe recently aware of lead, usually the first time people encounter lead is maybe through fishing, those lead weights. Lead is quite dense. It's 11 times heavier than water, and obviously helps things sink when you're fishing. It's water resistant, it's malleable, ductile. If you encounter lead in kind of a sheet form, if you haven't encountered it before, you'll be quite surprised of how malleable it is. Very easy to manipulate, very easy to work with. It then maintains that structure quite well, um, and very easy to penetrate. So if you were to, approach it with a screwdriver or something like that, you could get through it pretty easily. It's quite soft, quite malleable, which makes it very easy to work with. It's got a low melting point. It's electrochemically protects iron from corrosion, which is one of the main reasons that it's used so extensively on, rust-resistant paints and whatnot. And it was known as a poison since ancient Roman times. They actually used to add lead to tea primarily because it was sweet. They used to drink lead, which may be news to some individuals. We don't do that anymore, or at least we try to avoid it. So architectural paints, historically, so from the 19 or 1880s to 1940s, US and Canada, lead oxide was present in paint as a hide. It was also to improve rot resistance. So lead was kind of a good thing to add into paint at the time. It made it a lot more resistant, a lot stronger. It made the colors more vibrant. It was resistant to rot, which was, a huge component to why it was used so extensively. But it's hazardous when it's in poor condition, when it's ingested. There's a number of old news articles or images of children, chewing on windowsills. And if anybody's, got kids, they know that, most things go into kids' mouths, and what you don't want it to be is a lead-based paint on something. So it can become hazardous when it's in poor condition, when it starts to flake, starts to delaminate. During renovation, obviously, when it's being disturbed, being released into the air, depending on the method of disturbance. And then we obviously want to avoid that direct ingestion, primarily with children, because children and fetuses are at the greatest risk. While I won't go into them here, there's very detailed US Housing and Urban Development, or HUD, EPA and EPA regulations available. Talk a bit about the Canadian limits on lead and paint. There's been a bit of a history, so a lot of people are curious about kind of the phasing or reduction of concentration of lead over the years. So in 1976, Canada limited lead in interior consumer paint to 0.5%. There was no restriction on exterior industrial commercial paint, which you may see as kind of a trend as we go through here. In 1991, the Canadian Paint and Coatings Association initiated a voluntary program to limit the Canadian manufacturers to consumer paints to 0.06%. What we found is that over 90% of paints sold to consumers were part of that membership. So they were following along with that 0.06%. In 2005, Health Canada's surface coating materials regulation limited the consumer paints, enamels, and other surface coatings to that 0.06. In 2010, the Canadian Consumer Products Act, which is surface coating materials regulation, limits lead in certain paints to 90 ppm, which is 0.009%, but industrial paints were noted as exclusion. So what you might find is paint applied, like rust-resistant paints applied to bridges or on steel beams. They were not part of that limit of 0.009. And then in 2006, there were some further exclusions, but nothing that noticeable, nothing that extensive. So a couple applications of lead that we see, you've heard me talk about rust inhibiting paints. Where you'll find that is basically anywhere that, could be exposed to the elements where you want to prevent any rust. So 10 to 40% lead in bridges, water towers, industrial equipment, marine applications. It is still, available and applied in limited production because it does not fit into that criteria. It's an exclusion. What you'll find oftentimes with this type of material is a higher risk disturbance, typically through abrasive blasting. So if you were to decommission a bridge, you could, remove the point of contact if you were to torch cut the bridge apart, gel strip away that portion where you're going to cut. But oftentimes, due to the scale of the work, you'll see abrasive blasting torch cutting, and these can create very high exposures for lead. So there's oftentimes pretty extensive um, work areas, enclosures, PPE required when it comes to kind of de-energizing and disassembling larger scale bridges. Another thing to consider when it comes to these outdoor settings is environmental protection. So when you are, say, sandblasting, what you don't want to happen is to, sandblast all that lead paint off and then have it release into the environment. You don't want that getting into the groundwater or into the soil and contaminate. So there are some pretty extensive environmental protection regulations to minimize the spread to surrounding surfaces. Again, there's some strong US OSHA regulations associated with this. Lead in its metallic form or more of its elemental form is also common. So where you'll find this, typically in older buildings, you'll see lead in solder. This would be associated with electronics, tin cans up until the 1980s, eaves troughs, basically any plumbing work. You may find lead pipes as well. We still encounter those in older buildings. Again, a little bit easier to differentiate since it is so malleable. You'll often see that it's been manipulated in some way that a steel pipe or something like that would not be. Sheeting for acoustic insulation. I touched on this a bit before. You can see it in this bottom right section. This is lead sheeting. You can see how malleable it is. Like I said before, we would encounter that maybe between tenant units in commercial settings, above the walls, in a ceiling plenum, something like that, to create a bit of sound barrier between the two units. Corrosion resistant paints and coatings, we just talked about. Bullets, we've touched on as well. So, bullets have a lot of bullets are lead based. Copper bullets traditionally are more expensive. Lead is kind of seen as a cheaper version. I believe there is an intention to shift more away from the lead bullets, but I don't think there's been any regulations associated with that. And then you have the pellets from shotguns, most likely, and then fishing sinkers. Ballasts, radiation shielding, which I've talked about as well in wall cavities to protect against that radiation, typically in an X-ray room. So if you manage or take part in a healthcare facility or dentist office, anything like that, not uncommon to open up a wall and find lead sheeting within that system. Masonry plugs, and then glazing for ceramics. You can also encounter lead. For cast iron pipes, you've got the bell and spigot joints. So this is one it's often missed or potentially overlooked. A lot of older facilities have this, cast iron system. They've got this bell and spigot joint here. Because there wasn't, a tight-fitting coupling when you worked with cast iron, there was no, screws associated with it. There was no threading. Sorry. This needed to be filled in order to create a tight seal. So here you've got the bell and spigot, and you can see a closer look in here. There's a lead packing in here. Oftentimes, again, this isn't an asbestos training, but oftentimes what you'll also find in here is asbestos packing stuffed in this gap here, and then this tight seal is created by pouring lead in. So when you see these on your facilities or you encounter these as part of renovations, always good to keep in mind that there may be an asbestos and lead component associated with these bell and spigot joints. Oftentimes what is done is, when you go to remove it, you kind of cut away the cast iron. You're not like scraping all this out or anything like that. You're just kind of cutting the pipe into sections and disposing it. Pointing mortar. This is traditionally in, again, older facilities, but more of a decorative component. So we see this on historic buildings with, stone facades that, want to have a decorative appearance to them. Pointing mortar, it was about 5 to 10% lead, and the lead was added to whiten the mortar, make it very flashy and very clean looking. It's also 45% crystalline silica, but when it comes to restoration work, it can produce very high lead, depending on the method of removal. Oftentimes, if people aren't aware, they're grinding this material out, and that can create a significant amount of particulate or dust being generated. So there's obviously lead exposure potential, but there's also a significant amount of silica. So there could be a silica exposure potential as well with that. And then leaded gasoline, something we haven't talked about in a while, not something that's been around for a number of years, but the tetraethyl lead was added as an anti-knock. So an anti-knock, if you're not familiar, is basically the leaded gasoline allowed the fuel to burn more effectively. It prevented the engine from making a knocking sound. So essentially an anti-knock. The engines weren't as advanced as they are now, so it was more of like a reduction in sound, basically, that lead gasoline. Began to phase out in about the 1980s. But while it was being used, it created a pretty significant and widespread contamination of the air, the soil, and the cities. So, as an example, in 1975, the airborne dust in Windsor was about 2% lead. So, what we found in those areas is that older buildings that may not have been cleaned or maintained, that have a lot of settled dust, that settled dust can contain, noticeable lead concentrations without any interior source being present. So there's a number of factors that need to be looked at when we go to sample lead or dust. If people come to us and say we've got a concern for lead dust in our facilities, we have to look for potential sources, history of the building, cleaning frequencies. There's a number of questions and information that we'll look to gather in order to try and identify the source of any potential lead contamination. Haven't seen any questions come through, but again, there's plenty of time for any questions or open discussions. If anybody has anything related to kind of the lead uses, applications, by all means, throw it up. Otherwise, I'll get into the health effects. Okay, perfect. So we'll talk about the health effects, primarily understanding the routes of entry, how lead poisoning can affect the body, how lead is measured in the body, and signs and symptoms of lead poisoning. So when it comes to lead, route of entry is obviously something we need to consider, which is how chemicals or agents enter the body. We need to understand which routes of entry are compatible with the physical state of the chemical, and we need to understand the types and effects of exposure. So what do the chemicals actually do to our body? So when discussing lead and considering lead, there's a number of potential routes of entry for lead. Ingestion is the primary route of entry, primarily with children, as we talked about. So ingestion is the consumption, eating the material. Um, a very large concern for children. Inhalation is another aspect. So if lead does get into the air, we have the potential to inhale it. When it comes to inhalation, once lead, if released, is settled, it is more difficult to kind of have that lead re-enter the air. It has to be pretty significantly disturbed to release it. It's not like as I said before, lead is very dense. It'll settle and be tough to actually get it back into the air, unlike some other materials where maybe it's quite light and small breeze or little disturbance can release it back into the air. That's not exactly where lead fits. And lead can also be absorbed. So this is a bit of a secondary issue, but it can absorb through the skin, and then when we inhale it, absorb into our lungs and into our systems. So types of exposure, there's acute and chronic. Just a bit of context in case you're not familiar. So acute is large doses over a short period of time. Chronic is repeated exposures over a long period of time. The acute can be attributed to accidental exposure, so maybe a significant one-time release or any kind of system failure. So if you take like a firing range or something like that, where the system fails and then the people aren't aware, you can create kind of an exposure situation. but it would be considered short term as, it would be interpreted that that would be resolved quickly. With chronic exposures, they're relatively smaller doses. Asbestos workers may be fitting into that kind of exposure potential where the primary concern is asbestos related work, not so much considering the lead potential. And they may be just being exposed to smaller quantities of lead over longer periods of time based on the nature of their work, the disturbance of materials, typically in older facilities, as there would be asbestos, because that's why they're there. So inhalation, not often a concern from household contact, right? My my wife, girlfriend at the time, used to live in High Park in Toronto, and she had an older house for sure. And one time I was a tech, had an XRF. For those who aren't familiar, it's kind of a lead gun where you can determine the rough estimation of concentration of lead in the walls and scanned it, and it was the highest concentration I'd ever seen, despite being in the industry for about 3 years at that point. So basically my guidance to her was, don't lick the walls and you'll be all right. So it's not likely that, just day to day, walking around, living in a facility like this, it's not likely that it would be a concern through inhalation because it does not readily become airborne unless disturbed. Where we're concerned primarily with inhalation is higher or more aggressive forms of disturbance. That would be welding, cutting, abrasive blasting. That's going to release either lead fumes or high amounts of particulate into the air. And obviously, those need a higher classification of risk, more PPE, more controls for handling. Absorption from inhalation. So the body absorbs lead. 50% is of airborne lead and dust particles can be absorbed into the body. 90% of finely divided dust and lead fume is absorbed once it's in the lungs. So absorption of lead into the bloodstream is pretty significant once it's inhaled. So we want to keep that kind of finer particles, that lead fume especially, or very fine lead dust, away from our systems because it can absorb, once inhaled, can absorb very quickly and very readily into our body. The one that comes primarily to mind is torch cutting, say a steel beam with a lead-based primer on it. That can have significant release of lead fume. Ingestion, which we've talked about a number of times, the body absorbs and transports it like calcium. It's the major route of entry for children, primarily through household contact. Um, Children need about 200 milligrams of dust per day, absorb about 50% of ingested lead. So we want to keep that lead potential away from children or individuals more susceptible to that exposure. Adults absorb about 10% of ingested lead, so much less, and pregnant women absorb about 50%. So again, we're into the children and pregnant women are at the highest risk when it comes to absorption or ingestion. Sorry. Lead in the body. Lead circulates pretty quickly and extensively throughout various organs and systems. The distribution, which you can see here, soft tissues about 2% stored over about 30 to 40 days. In the blood, about 4% stored for about 27 to 36 days. Once it gets into the bones, it's stored for about 25 plus years. So we want to avoid that absorption and transfer into the bones as much as possible because it is held for much, much longer. How do we measure lead in the body? Oftentimes this is done through blood tests. The blood tests are great for showing absorption over the previous 6 to 8 weeks. It's not going to tell an extensive history of lead absorption throughout someone's lifespan. It's more of a one-time or recent exposure type of test. Uh, the results are expressed in terms of micromoles per liter in Canada or micrograms per 100 cc in US regulations. The current maximum acceptable blood level from the ACGIH is 1.3 micromoles per liter, as a bit of context there. Lead poisoning, this can affect a number of different things. So once lead enters the body, it can have a number of different effects. It can affect the nervous system. It can cause permanent nerve damage, tremors, irritability, depression, death. Once it gets into the marrow, it can cause anemia and high blood pressure. It can cause kidney damage, kidney failure. It can affect the male and female reproductive system. So it can cause infertility. It can cause spontaneous abortion, birth defects, sexual dysfunction. It is not a great material to absorb or enter our body. So some of the signs and symptoms of lead poisoning, there are a number of them. I'm not trying to downplay, lead exposure and lead symptoms. It can be tough to identify some of the times because I think, on a rough day, some of us may have a number of these already, but you may encounter symptoms such as tiredness or fatigue, dizziness, irritability, headaches, forgetfulness, numbness of limbs. That's obviously going to be a little bit more noticeable than some of the other ones. Depression, difficulty concentrating, sleep deprivation, nervousness. I mean, most of these, if you've got a young child, you've kind of nailed most of these already. Um, Wrist or foot drop, that's more significant related to lead. Weakness, clumsiness, joint and muscle pain, vomiting, loss of appetite, stomach aches, constipation, metallic taste in the mouth, and reproductive problems. So there are pretty extensive health effects and symptoms associated with lead that we need to be concerned and aware with. There's been a couple of questions in the Q&A and the chat, which is great. I'm hoping to address some of those questions in the next several slides, but if I don't, I will get to them at the end. Okay, regulatory requirements. Hopefully everybody's got a coffee. I'm just kidding. It'll be fine. We'll get through it. It's really important information. Maybe the reason some of you are here is better understanding what's actually required for the regulatory requirements associated with the lead. So when it comes to dust, there's no Canadian limits for lead and dust. We defer to the US standards, so US EPA limits for houses. So there are certain concentrations for various settings based on the sensitivity of the site or the location of the dust, so versus floors versus windowsills. What's more accessible to various age groups is something that was certainly considered. So you got a couple of different values you can see here. It's divided into kind of systems of a facility. The U.S. Navy criterion for cleanup of former fire range related facilities is about 200. We need to understand the location, the sensitivity. So a residential facility will have, higher expectations than an active firing range where it's likely going to be continuously contaminated. So we need to have more of an administrative approach to controlling exposure alongside some physical controls. Air, we do have a regulation for. So this is the time-weighted average or occupational exposure limit. It's set out by Ontario Regulation 49009, which is the designated substances regulation. That time-weighted average or occupational exposure limit is 0.05 milligrams per meter cubed. Sorry. So to put that in a bit of perspective, that 0.05 of lead in air, I mean, how much are we talking about? This is a great kind of visual representation of that. This spec from a 1 gram pack of sweetener is 0.05 milligrams. So it's about that amount in a meter cubed. So very small quantity is permitted as part of that time weighted average. Very small amounts of lead is permitted. For those of you who may not be familiar, a time weighted average or an occupational exposure limit is a value or a concentration that your average worker can be exposed to without adverse health effects. So that would be a person working 8 hours a day, 40 hours a week, 30, 40-year working span. So under 49009, there are some duties of the employer. They need to take every measure so that airborne concentrations do not exceed. This is kind of a catch-all statement. You need to make sure you're doing everything within your power to make sure that this time-weighted Time weighted average or occupational exposure limit is not exceeded. If you're familiar with health and safety, looking at the list of attendees, I know a number of you are. Respirators are always seen as the last line of defense. There are a number of other approaches that we can take, whether it be elimination controls, administrative approaches. Those should be the primary focus for reducing the lead potential. Respirators are, if all of those things cannot be implemented, respirators are kind of seen as that last line of defense. Also very appropriate for emergency situations. So obviously you can't implement a physical control into every emergency situation. So there are situations where you need to bring in the respirators to access the space. Or if there's a temporary breakdown of those systems in place that you already have. The Occupational Health and Safety Act primarily touched on with a lot of these potentially hazardous materials. Again, the catch-all statement, Section 25, employers shall take every precaution reasonable in the circumstances for the protection of a worker. This means that the MOL can enforce lead guidelines, essentially. Uh, Section 30, if you're not aware, talks about the requirements to have a designated substance survey prior to planned or tented work. That would identify the designated substances that may be impacted by the work, and lead is a designated substance. So in your typical building, call it a commercial building, a school, retail, what we're primarily looking for as part of those designated substance surveys is asbestos, lead, mercury, and silica. Not to, stray too far away from the conversation, but there can be a bit of confusion around the difference between a designated substance survey and a hazardous building materials assessment. A hazardous building materials assessment is essentially a designated substance survey. It captures all the designated substances, but it adds PCBs and mold most often. And PCBs and mold are not considered designated substances, but they are hazardous materials that often people want to know about prior to work. So I don't want to necessarily, apologize for the confusion there because it is like kind of an industry-wide approach, but there is a slight difference there that can be considered. But what we have available to us are also some lead guidelines. So there's a lead guideline from the Ministry of Labor, guideline for lead on construction projects from 2011. It sets out the training requirements, it classifies work operations, it establishes the measures and procedures and personal protective equipment. It also provides guidance for medical surveillance. So lead can be somewhat difficult to understand all of the requirements. Essentially, what's regulated is that time-weighted average. You cannot exceed that time-weighted average as far as airborne exposure. But how can you transfer maybe a bulk concentration of lead to an airborne potential? What the MOL did and what EACC did as part of their lead guideline for construction, renovation, maintenance, and repairs from 2014, they're quite similar. There are some differences, obviously. But what they did is they were able to run a number of tests. They were able to complete a number of assessments and basically correlate a bulk concentration with a method of removal and identify the airborne exposure potential. And we'll talk about that in a second here. So they were able to identify bulk concentrations that had a higher likelihood of maybe exceeding that airborne exposure potential. So they were able to classify lead into a number of different concentrations. Lead-based is anything higher than 0.5% lead. That's considered, elevated levels, lead-based. Lead-containing is between 0.1% and 0.5%. So slightly lower classification, but still relatively high or elevated. And then low-level lead is less than that 0.1%. Various consultants will also treat less than 0.009 as an insignificant amount of lead. So the potential for exceeding the time-weighted average, despite the method of removal, is very, very unlikely. or insignificant. So disturbing lead of that low concentration, that less than 0.009 is not considered a risk. Whereas disturbing lead of these concentrations has the potential to exceed that time-weighted average, depending on the method of removal. So they've organized the methods of removal into various classes. They're shown here. And I'm not going to go into massively extensive detail into the various classes, but give some summary to give some perspective. Class 1 is considered the lowest level of risk. The methods of removal defined within class 1 have a very low chance of exceeding that regulatory amount of 0.05 as part of the time-weighted average. Class 2, the methods of removal are a little bit more significant. They are likely going to cause more of an airborne potential, so they now need a higher classification. They need more controls in place, more personal protective equipment. And then class 3 is the higher level of risk. Those methods of removal, which includes the 3B, which is abrasive blasting, which is considered a very high potential for lead release. Those classifications, those methods have a higher likelihood of exceeding that time-weighted average. So these guidance documents, these guidelines, were able to kind of correlate a bulk concentration with a method of removal, classify them according to potential exposure risk associated with that time-weighted average. That makes sense to everybody. Hopefully it does. So just a couple of examples of what's considered class 1, class 2, or class 3. Class 1, again, that's kind of the lowest level of risk. It's removing lead-containing paints or coatings with chemical gel strippers or pastes. So, you're not creating a disturbance that would release, any kind of significant amount of particulate. You're applying a gel stripper and then cleaning that gel stripper off. So the material is remaining wet. Obviously, you can understand that that would, create very little dust generation. Another class 1, removal of materials relatively intact that have lead-containing paints or coatings. So, if you were to remove a door in its entirety that had lead paint on it, obviously you're not creating a whole lot of dust in that process. Class 2, using HEPA-filtered power tools to remove lead-containing paints. If you're not familiar, a HEPA-filtered power tool is considered a power tool, typically a handheld power tool that has a dust collection shroud that collects the dust at the source, and that shroud is then connected to a HEPA-filtered vacuum. Class 2, another one, removing lead-containing paints by manual scraping or sanding. So now you are into more of a dust-generating process, but this one is just with hand tools. And then class 3 is using power tools without HEPA-filtered attachment to remove lead-containing paints. And then the 3B is the abrasive blasting, which is considered a very high potential for lead exposure. When it comes to inspection and air monitoring, not a whole lot of, no regulations on the requirements to do this. There are some industry standards, there are some best practices, very similar to asbestos abatement, if you're familiar with that. The types of inspection that we would typically do are visual. So this would be primarily, we would start with the pre-start or the pre-contamination. This is an inspection of the containment or the work area, making sure that there's all the necessary submittals, work signage, equipment, decontamination, ventilation controls, all these types of things, making sure that everything is in place to complete the work properly from the start. We would do also during work inspections or site reviews. These are to ensure that the work areas are remaining intact, that the procedures are being followed, that there is no unexpected methods of removal that are causing a significant amount of dust generation. So making sure the materials are adequately wetted, as an example, to make sure that you're not creating an excessive amount of dust. And then what we would consider a visual clearance post-work visual inspection. This one, you're inspecting the work area for cleanliness, the scope has been completed, that the equipment has been decontaminated, that all the waste has been properly packaged. There are situations where air sampling or dust wipes can be considered for clearances. This is typically done in class 3 work, not often done for class 1 and class 2. As I mentioned before, there's some Canadian federal acts and regulations. These apply to primarily discharge of lead into the environment, such as waterways. There's a number of different ones. The Environmental Protection Act, the Navigable Water Protection Act, the Fisheries Act. These are all intended to ensure that the lead is not transferred into the natural environment, such as waterways, soil, and air. These are particularly important for outdoor work, specifically around bridges primarily. We've also had some pretty extensive lead paint removal from the exterior of buildings. And essentially what has been done in the past is you create an enclosure or a poly structure around the entire building with various dust collection sources and prevent any kind of runoff from any water being used. You're essentially containing the building as you work on the exterior of it to make sure that the lead is not, transferring to adjacent spaces or into the environment. These regulations that I've mentioned, they apply to every employer or worker at a workplace where lead is present, processed, used, handled, or stored, in which a worker may have the potential to inhale, ingest, or absorb lead. Trying to go through some of the questions. So I'm hoping I answered a couple of these. Is there a lead concentration that we need to watch out for? There is when it comes to air, for sure. That's that 0.05 as part of the time-weighted average. We don't want to exceed that airborne concentration. As far as bulk concentrations, that 0.1% is where you would typically see recommendations for specific handling procedures, no matter what the method of disturbance is. So our recommendations, if the concentration exceeds 0.1 in a paint or something like that, any method of removal would warrant a lead abatement procedure. When you get to between 0.1 and 0.009, that low level area, but not insignificant, based on our experience, lead procedures are recommended if you are aggressively disturbing it. If you have a higher potential of releasing lead into the air, then you should have lead abatement procedures, and that would be torching because of the fumes, grinding, and abrasive blasting. So hopefully that answered that question. Yeah, important to a couple notes here. EACC guideline, a guideline specifically. So the regulation that applies is that OREG 49009 that applies to the airborne concentration, but the EACC, the MOL are guidelines. They're tools that can be referred to, but are not regulation. Important noting. Yeah. Someone notes that they live in an older section of Toronto. Homes are constantly being demolished and rebuilt. Does the City of Toronto require hazard assessments prior to demolition of buildings? Yes. In short, there is a demolition or a demo application that needs to be submitted for the City of Toronto. Within that permit, there is a requirement for a hazardous building materials assessment, which would incorporate the lead. It's obviously a designated substance survey, hazardous building materials assessment, both would capture the lead component. So yes, I mean, I can't speak to every specific project, but according to the requirements, yes, there should be a designated substance survey or hazardous building materials assessment prior to any demolition in the Toronto area, specifically under the City of Toronto. Couple asking, would respirators be the best form of protection for workers who move from site to site in any given day and don't necessarily have a workshop and work in? Uh, yes. Like I said, PPE respirators, they're considered the last line of defense, but sometimes they are the most appropriate. You want to make sure that they also have, adequate training, which would fall into the administrative portion of things, understanding the potential risk, the potential exposure, and understanding the requirements around the PPE, how to properly maintain and use and store and clean respirators. But yes, if you are moving around from place to place and you can't establish any kind of controls within that facility, then yes, respirators would be a good approach. Obviously, making sure you don't contaminate adjacent spaces. If controls or enclosures are needed, you would want to implement those to avoid any kind of cross-contamination. Okay, thanks for the questions. I think I've got most of them. So control strategies, this is kind of what we've been touching on or leading up to. This is kind of that, it's not exactly the hierarchy of controls, but there's a couple of different elements or controls that can be implemented through a lead control program. Engineering controls, so this would be, ventilation. So if you think of maybe roughly think of like a paint booth that would have a specific facility with increased HVAC requirements or ventilation. Work practices, just because you can use a power tool doesn't mean you have to. Maybe you can use a hand tool as an example to reduce the potential exposure through work practices. Hygiene practices, this is very important and very relevant when it comes to, say, a firing range. So, there's a number of different components to firing ranges. There's the range itself, there's, cleaning rooms, there's the actual HVAC room itself. There would be certain hygiene practices that you would implement, regularly cleaning, tack mats for entering and leaving, proper decontamination, washing hands and face, all those different things can be implemented over the course of the process of entering and then leaving that facility. Respiratory protection, that's obviously going to have a respiratory protection plan, include a number of different elements that I've already talked about, the proper care and maintenance, use and cleaning of respirators, identifying the type of respirator that is applicable for the certain method of removal or disturbance that you're completing, the type of cartridge that you need associated with the respirator or filters. If you have a facility, again, thinking of a gun range where like the potential for lead exposure is always going to be there because that is the system in place. You may implement periodic monitoring. That can be air monitoring, that can be wipes to ensure that the cleaning activities or the HVAC system is working adequately. And that frequency may depend on the nature of the facility, its use, and so on. Alongside that, you may also implement a medical surveillance program. So again, if you are, let's say, a lead abatement worker or a police officer that does a certain amount of hours in a firing range, a medical surveillance program is also a good way of monitoring the adequacy of the collection systems. And then work records. So this is more applicable to lead abatement workers, indicating how long you were doing the work and what type of work you were doing. Engineering controls, this primarily applies to lead abatement. So when it comes to lead abatement, there was the class 1, class 2, class 3. As you kind of increase your risk through those, you will implement various engineering controls. They may include enclosures. And this is a couple of images of enclosures of various types for lead abatement. Basically, you're isolating off your work area, creating an environment that you can control and clean, and prevents the contamination or cross-contamination or potential exposure of adjacent occupants. We've also implemented on occasion local exhaust. So if you have to, let's say torch cut inside, that's something that you're going to want local exhaust, basically collection of that fume or that particulate at the source. Work practices, touched on these as well. These would be the housekeeping, the maintenance, the signage, basically anything that can be done administratively to reduce the potential of exposure. When it comes to lead abatement, the sign here is kind of a rough example of a signage. What you don't want to happen is, a bystander or a fellow construction worker enter into a lead abatement work area without the proper PPE or training. So there's signage that is installed to prevent anyone from entering without the necessary requirements, warning them of the hazard and the respiratory protection requirements. Hygiene practices, this can be applied through various elements of lead associated work. As far as abatement goes or removals, the hygiene practice of facilities, this is going to be, decontamination. Oftentimes, this is going to be, wearing Tyvek suiting or PPE, and then decontaminating through washing and disposing of those Tyvek suits, and then washing hands and face. The hygiene practices would also apply in, lead environments such as fire ranges with frequent cleanings on a routine schedule. How you actually do this is when you're leaving a facility, you're cleaning off the Tyvek suit. This would be vacuuming, wet wiping. You're disposing of that Tyvek suit as a contaminated a bit of PPE, and then you're doing a decontamination through typically a bucket with soap and water and towels, and washing your hands and face, cleaning off your respirator, all that kind of stuff, so that we don't have any cross-contamination or transfer of lead out of a work area. On occasion, showers may be implemented, typically for higher risk operations where contamination is likely. And then obviously throughout abatement, you're making sure that workers aren't eating, drinking, smoking, vaping, or anything like that, any kind of potential ingestion. You don't want to have any kind of like hand to mouth contact while lead is being handled to avoid that ingestion. And then PPE, talked about a bit. Appropriate PPE can be a number of different things and can apply to various types of work environments. So obviously, respiratory protection. There are in the guidelines available, there's a number of different respirators that are best suited to the type of removal or method of removal. So always a good idea to cross-reference that for kind of best practice on what respirators to be used for what method of removal. Tyvek coveralls, these are going to, prevent contamination of clothing and basically create kind of a head to toe isolation for the worker. When we're talking about general construction, obviously we're thinking about safety footwear. We're thinking about cut resistant gloves. When it comes to lead work specifically, we want to implement nitrile gloves to prevent any absorption through the handling of lead. If you are doing a method of removal, maybe hand tools, scrapers, or something like that, you may also want to consider cut-resistant gloves to prevent against that protection. If you're anything like me, I mean, I've done many, many surveys, and the amount of times that I cut myself is pretty frequent. So I've very early on in my career, I implemented cut-resistant gloves because things happen whether you're using a chisel or something, and you just put a bit too much pressure on, you slip, it can cut. So same can apply for removal. You want to make sure that you're protecting yourself, which is cut-resistant gloves are a great way of doing that. And then anything else that may be required as part of the construction facility. So if you or construction site, If you are doing lead abatement on occasion or relatively frequently, that may be part of a larger construction site. So then you want to comply with all of those requirements as well. Hard hats, boots, high-vis vests, all that kind of stuff. And then, as you enter into the work area, some of those may still apply. As far as respirator controls and respirator care, there's a CSA standard, it's the Z94-411. It sets out the requirements for selection, use, and care of respirators, and for the administration of effective respiratory protection program in the workplace. So if your employers do require or use respirators, it's a very good idea to have a respirator control program. The CSA standard can offer a lot of support with that and offers a lot of valuable information and what is expected when it comes to respirators. So when should respirators be used? We've touched on this a little bit. It should be considered the last resort, um, appropriate when engineering controls or work practice controls are not practicable. The example that an individual gave of moving from place to place within a work area when administrative controls are not feasible for work that's short in duration or low frequency and maybe temporary use, such as emergencies. The respirator protection program that I've touched on, here's a number of different elements. It is mandatory when respirators are used, and here are a couple elements that can be implemented into that or should be implemented. Roles and responsibilities. This is an essential part of any program. If you have an asbestos management program or maybe even a lead management program, defining roles and responsibilities can be crucial so that everyone understands what their place is in the company and how they are to respond to various lead situations. Hazard assessments. This is um, highly implemented in industrial settings when disturbance of lead is more frequent. A hazard assessment can be completed for each task that is performed and identify what the PPE or what the controls are and what the training is in advance of that. That hazard assessment component can be relatively simple based on the nature of your business, or it can be quite extensive if you're in more of a high lead environment or an industrial setting. It'll talk about the respiratory selection. So, what type of respirators are chosen for each type of work, maybe based on the hazard assessment. The training requirements for the staff, if individuals are just working around lead, they should understand the potential risks associated with impacting it. Whereas if they are impacting it, they can receive training on, how to properly erect enclosures, what PPE to select, all of these different things associated with actually disturbing the material. And then if you were, say, a lead abatement worker, then you'd have a higher level of training because that's now your main role is disturbing lead. Fit testing. So for every respiratory or respirator, you need an effective seal measured by a fit test to be done every 2 years, can be qualitative or quantitative. That's a portion of this respiratory protection program that should implement the requirements for that. The use of the respirators, the cleaning, inspection, maintenance, and storage of respirators, that's a very important part of this. Once an individual has a respirator, they need to understand fully how to take care of that respirator. I've seen a number of different respirators in various conditions. They need to understand that you can't put a respirator in the trunk of your car in the middle of the summer, covered in boxes, and you're not expected to warp and become misshapen. You need to understand how to prevent mold growth within a respirator and how to prevent any kind of contamination. It'll talk about health surveillance when the program needs to be evaluated. So whether that program should be evaluated annually or maybe a change in condition of operations, whatever it might be. And then record keeping. So that might be the work reports or depending on your facility, maybe designated substance surveys or abatement records, something like that to showcase that there's been a number of different records. But the respiratory protection program, mostly it's going to include fit test records and work reports. And then for the last little bit, we're going to touch on lead abatement options. Just a few examples to kind of showcase how we might classify lead. So when it comes to lead-based paint abatement, there's always going to be a requirement for some kind of facility, work environment, cleaning operations, PPE. We're not going to go into that in great detail here, but it's important to note that when you are disturbing those lead-based paints or lead-containing paints, that the classifications and the lead abatement work is going to require a level of protection, which would typically be PPE, containment, and various procedures for handling. So an example here, a component removal that might be removing the door is a great example. So if you're removing a door with lead paint on it, considered a class one operation. Half-face respirators are indicated as optional. Again, you're creating a process or you're completing a procedure that is going to generate essentially no dust or shouldn't create any dust. So the respirators are considered optional. You'd have coveralls, moderate dust containment, and you want to make sure there's hygiene precautions for ingestion risk. So that is the no eating, no smoking, no drinking, no vaping type of thing. With every type of lead abatement, you want to make sure that there's thorough, careful cleaning, often done through HEPA vacuuming and washing. It is an essential part. There's Lead Dissolves is a proprietary effective cleaner of lead dust, so that's an example we like to throw it as there are some key products that can be used to assist and support with the effective cleaning of lead. Chemical paint removal or gel stripping is another option that we see a fair amount. Where we see gel stripping a fair amount is say you've got elevated lead concentrations on a beam and work is required to maybe weld on something to that beam or bolt in something to that beam or cut that beam. What we'll often see is rather than perform the method, you know, the torching or the welding, rather than have that done as a lead abatement procedure, we would gel strip away the lead paint, so that it is a clean environment to proceed with that work. It's using a low risk operation, class one, to remove the lead to avoid a high risk operation such as torch cutting lead containing paint. We do not recommend using methylene chloride based strippers. They can be applied to woodwork, often used on non-porous surfaces. There's very little airborne dust associated with this. We talked about this before. You apply the gel stripping, you leave it for a number of hours based on what the product requires or how thick the paint is, or there's a number of factors. You come back and then you strip that paint away, often with hand tools, wet wiping, that type of thing. Scraping of paint, talked about this. This is going to be a higher classification of risk because now you are disturbing the paint. You are creating a potential for airborne dust. You're creating particulate, depending on the size of the particles generated. It could be going from a class one to class two. Scraping of paint, class 2A operation. This is common with historic restoration work. Oftentimes, if we need to keep that system in place or that building component in place and in good condition, we'll scrape away or sand away that paint. There's a number of different tools that can be used to remove the paint, but this was going to require the half-face respirator, coveralls, and moderate containment. Again, there is a higher likelihood of dust generation through this process. Dust-controlled power tools in the 2A operation. This is a pretty common approach to handling lead. It needs to have, when using power tools, in order for it to be class 2A, it needs to be an effective dust collection, which means you have a shroud collecting dust at the source of release and connected to a HEPA filtered vacuum. A couple example needle guns and grinders. What we often see are grinders with lead. It's really great for localized removal. It can be quite time consuming if you were to say try and remove all of the lead paint from a block wall. That can be quite time consuming, but it will be most often more effective than a gel strip. Um, when kind of looking at that situation, removing paint from a block wall, there's benefits to both. We've seen both work effectively. Applying a gel stripper, it can take a while for that gel stripper to work. It can take a number of different applications. The material is porous, so it's going to be hard to get into all the different pores of that block wall with the gel stripping. Um, Grinder is going to be more effective, but it obviously is going to impact the block wall itself. And it can be slow and noisy if trying to work in or adjacent to an occupied space. Abrasive blasting, this is kind of considered the highest level of risk classification, touched on it a number of different times. Class 3B operation. It's been proven to be very effective with structural steel, tanks, um, but it does have a very high potential for exposure. Uh, it's going to release very fine particles of lead through the abrasive blasting. Um, we also need to consider the waste associated with it. So now you've got, a lot of that shot waste or blasting waste that has lead within it. So we obviously want to make sure that we're analyzing that waste and making sure that it's going to the right facility. That's done through what's called a T-clip analysis to make sure it's basically a leachate test to make sure that the lead is not leaching from the substrate or from the waste and getting into our groundwater at the waste facility. It needs airtight containments. It needs very large ventilation systems. Oftentimes, more often than not, it's going to be supplied air, wash stations, showers, medical surveillance, ambient air monitoring, depending on where it is, if it's outdoors, soil monitoring, and then it will have clearance requirements as well. When it comes to cleanup, there's a number of different methods that can be used for cleaning. The most effective is going to be vacuuming and wet wiping. It's a little bit more controlled. Power washing, if you can control the runoff, is going to be quite effective as well. If cleaning of surfaces isn't achievable, so sometimes the surface is porous, the cleaning methods aren't as effective. Encapsulation can be used as well. This can be with a paint or an encapsulant. There are requirements or criteria. I won't say requirements because it's a guideline, but EACC does offer some um, clearance criteria for wipes. And you can see here, looking at the various ranges, depending on the location of the area the surface being tested, there's going to be different levels of clearance criteria. I'll keep that up for a second. So you can see, obviously, you can see childcare facilities, primary schools, food prep having the lowest criteria levels and residential facilities. So that's it as far as the presentation goes. I do see a couple questions that I haven't addressed yet, but if anybody has any additional questions, feel free to throw them in. Um, Other than taking a wipe sample of surfaces and sending it to a lab, are there any other off-the-shelf products that you can use to detect paint and surface? Um, Not that I've seen work effectively. The most effective way of determining lead concentration, especially when it comes to wipes, as you're talking about, is going to be laboratory analysis. It's going to give a more accurate concentration, which can be then kind of compared to these criteria. So my recommendation would be to stick with the wipe samples with laboratory analysis. There's another question, why not use the methylene chloride stripper? It tends to off gas a little bit more than others. It's not always the most effective approach, and it can cause concern to some occupants based on typically high odors, and it has kind of in the past not suggested, but people have complained of headaches kind of when that's being used. So it's not always the best product to use based on the potential kind of adjacent concerns that come from it. There's a question here. Do we see the MOL changing their guideline or formally adopting the EACC guideline? I haven't heard anything specifically about that. So kind of in short answer, not to my knowledge. Just a couple questions. What would be the potential risk of lead being in paint in a high school that was built in 1985 and the second coat of paint is flaking? I mean, I honestly I couldn't give you an exact potential. The best way to determine that potential is to collect the bulk samples of the paint. Um, if the paint is separating, if it's flaking and you can see the underlying layer, you can sample both layers and determine the potential risk. But you'd have to do a visual assessment of the space to determine kind of the adhesiveness between the two layers and understanding the overall concentration. So I would say potential risk would be best known through collecting bulk sampling and doing kind of a risk assessment of that space. Just reading through. Will we have access to this recorded webinar so that it would be a great share with other parts of our organization? I'll have to double check with kind of our internal teams. We don't often share the recordings because they're considered more of a real-time application. We don't necessarily want them held for a number of years and then the information that we provide become out of date, but still relied upon. So let me find out about that. If I'm able to send it out, I will, but I don't believe that it's our typical approach. What are the guidelines of disposal of lead-containing materials? That's determined by OREG 347, which dictates the disposal of hazardous waste. What you would often do is if you have lead-containing lead-based paints, paint with kind of a detectable level of lead, you would collect a sample of that kind of with the substrate. What you're trying to determine is the potential for the lead to leach out of the material into groundwater at the waste facility. So you would do a leachate test, a T-clip, a TCLP analysis to determine how much the lead leaves the substrate or the paint or whatever it's applied to. Depending on the result, if it's considered leachable waste, it often goes to a separate part of a landfill that's, double lined and intended to avoid any kind of leaching of substances into the groundwater. A lot of times, newer transfer stations, new waste facilities, their entire system is double lined. So they're a little bit less concerned with the leachability because their whole system is designed to handle any kind of leachable waste, but that's not a guarantee. So always best to contact the waste receiver, understand the expectations before you actually drive there with the waste and give it to them. And then you would do a T-clip and a TCLP analysis and determine its leachability. And then the OREG 347 has the requirement. I don't know. I don't think I have you had experience with laser ablation removal of lead? If so, has air monitoring confirmed whether or not there would be airborne levels? Personally, I haven't had direct experience with that. So when I worked in British Columbia, it was kind of being implemented. My understanding is that that system is quite expensive, and there are um, more eff not more effective, but cheaper and just as effective methods. So laser ablation is not something that we see very often. Its effectiveness, I've heard, is it's quite effective. Its potential for release of lead, I couldn't speak to without a little bit more research. Um, it's something I would have to dive into a little bit deeper than be able to answer fully at this moment. It's a good question, though. Lead dissolves is a paint cleaner. Someone was asking if it what that was. It's a paint it's an effective lead cleaner. Oh, there are a couple more here. If we have an extra pail or two of paint, do we dispose or can we store it somewhere? And how long is it harmful to leave in the basement? Not to my knowledge, no. I mean, if you've got paint that's stored in your basement, properly covered in a well-ventilated area, like the concern from the lead, not present. Um, how it would be disposed of, two pails of paint or something like that, probably going to your local landfill. They take hazardous waste and often they treat all paint as just a separate hazard that they handle individually. Um, is, is lead dust sampling a necessary requirement for a designated substance survey for an older building? No, in short. Lead dust sampling is often completed if there's a specific concern or known potential release. It is not an inherent part of an assessment to collect dust for lead. You're collecting the sources to determine lead content. Why is there so many different units referenced for lead levels? Great question. People love to use different units. A lot of different regulatory bodies or groupings that create standards. I've found they don't always use similar terminology or similar concentrations. Um, I couldn't exactly tell you why each organization chooses what value. But yes, I do understand your frustrations there sometimes. There are various ways of showing concentration, and it's not always consistent. What do you look out for when assessing a contractor's certification as a worker who's qualified to work with lead? We, as Pinchin, we kind of hold our contractors accountable for their work. We have pre-approvals, so we make sure that they're fully capable. Um, Oftentimes, what you'll find there's no specific requirement here in Ontario, at least, um, for training certification for lead work. There's no portion of the regulation that details, you need to have this number of hours or this level of certification or this level of training. What we often look for is we'll ask for certification because a lot of times contractors will either have an internal training process or a union will have a training process. They'll issue certificates. We do those types of courses. We issue certificates to show that, they've received an appropriate amount of training, um, approving a contractor for like general abatement work. Um, Oftentimes, what we see is if a contractor is knowledgeable in, say, asbestos removal or asbestos abatement, um, they'll be equally knowledgeable in lead abatement. So to answer your question, there's no certificate necessarily. Um, you can ask for one. Um, Ideally, they'll have something to showcase that they've completed some training and are certified to complete the work. Thoughts on lead exposure for a water and fire damage restoration company? To what extent have you seen this? Can you provide some examples? Um, Water and fire damage restoration. So water restoration, the things that come to mind, lead paint, on drywall, lead piping associated with maybe an older system that's failed. There is certainly a potential for lead containing or lead-based materials to be impacted as part of water and fire damage restoration companies. Oftentimes what we'll see is, this flows through insurance work, and insurance will have sampling completed in advance. So prior to that type of work, disturbance of materials as part of a project, you'd want to have those samples collected and those potential hazards identified. So always best to have an assessment completed prior to removing those types of finishes and those types of materials to understand the potential risk. Hopefully that answers your question. Someone was asking, if the recording is available, is the presentation available? Yes, I think we can certainly do that, and I'll try and send it out to everybody. I can understand that there, can be kids running around, and I know that can be very distracting. So I completely understand what you're going through. So I'll touch base. Let me touch base with the marketing team, make sure that we can get this presentation sent out, but I don't think that'll be a problem to send out the slide deck. Some really great questions. I've seen them slow down a little bit. I think maybe everybody's gotten their questions addressed. Great. So if that's it from everybody, I haven't seen anything come in. Thank you so much for attending. I've left my contact information up here. If anybody has any questions or want to discuss, please let me know. We'll be happy to help. Otherwise, have a fantastic day and a fantastic weekend. Thanks, everybody.